In this video, we will look at how we make copper sulphate and cover the making salt required practical. We'll go through some of the background information and the method that you need to know. When thinking about the production of copper sulphate in particular, we first need to think about making salts. So a soluble salt can be prepared by reacting an acid with a suitable insoluble reactant, including a metal oxide, or a carbonate. The insoluble reactant chosen depends upon the particular salt required. For example, copper does not react with dilute acids, so copper salts are made using copper oxide or copper carbonate, not actual copper metal. On the other hand, sodium is too reactive to be used safely, so again, the metal is not used to make sodium salts. The general equation that we would use would be a metal oxide plus an acid will go and make a metal salt plus water. So specifically, we would have a metal oxide plus sulfuric acid would go and make a metal sulphate plus water. So for what we are looking at today, we would have sulfuric acid plus copper oxide, and that would make copper sulphate plus water. We can also go and make salt using a range of different acids. So when thinking about how these are named, the name of the salt is split into two parts. The first part comes from the name of the metal oxide, or metal carbonate, and the second part comes from the acid. Hydrochloric acid produces chloride salts. Nitric acid produces nitric salts, or nitrate salts. And sulfuric acid produces sulfate salts. So, for instance, if we had calcium oxide and we react that with sulfuric acid, we would make calcium sulfate plus water. If we had calcium oxide plus hydrochloric acid, we would make calcium chloride plus water. And finally, if we had calcium oxide plus nitric acid, we would make calcium nitrate plus water. So to very quickly run through how we would go and prepare some crystals of copper sulphate, you'd first go and react excess sulfuric acid with excess copper oxide. You would then stir for as long as possible, but no less than 3 minutes. This is to ensure that as much of the copper oxide dissolves in the sulfuric acid as possible. Next, you would go and remove the remaining or excess solid copper oxide by filtering it, which would leave a solution of copper sulphate and water. To go and remove the water from the copper sulphate, you could go and either evaporate it off or use a Bunsen burner to boil it off. The next short clip will show you how this can be done in real life. Sulphate, the first thing that we need to do is go and measure out. Right, when you do this, you would use a spatula, but measure out an excess of copper oxide, because it's going to be the copper oxide that you are going to react with sulfuric acid. You will then go and pour a certain amount of sulfuric acid in, and you will go and stir it for around 3 to 5 minutes. The longer you stir it for, the better your results will be. because the longer you stir it for, the more of the copper oxide will actually react with the sulphuric acid to make copper sulphate. So once you've gone and stirred it for an appropriate amount of time, we then need to go and filter off the excess copper oxide. So we get filter paper, we fold that into quarters. You then go and place that inside of our filter funnel. And we're then going to go and filter this, making sure that none of it goes around the outside through our filter paper. And that will go and drip through until we have a reasonable amount of copper sulphate formed. Once we have that copper sulphate, we can then go and evaporate the water off. So evaporating the water off can be done in two ways. We can either go and boil it off, or we can allow it to evaporate. If you allow it to evaporate, you end up with large copper sulphate crystals that look something like that. So hopefully that goes and covers what you need to know about the production of copper sulphate. Make sure you go back and have a go, or at least think about any of the activities, and if you have any questions, please leave a comment below.